Okay, in this video we are going to solve a problem of mixtures from the model of the previous video. Okay, so I'm going to read the problem. A tank, this tank, with 400 gallons of capacity contains 200 gallons of pure water. So I'm going to check this 400 gallons, 200 gallons, and pure water, because that is information now. So the tank has a capacity of 400 gallons. It doesn't mean it has 400 gallons of fluid. Okay, but it contains 200 gallons of pure water. Now, what does pure water means? Well, it means that it doesn't contain salt or sugar or whatever. It's just pure water. So that means that the concentration is equal to 0, because it doesn't have any material dissolved in the tank. Okay. Okay, brine is pumped into the tank at 5 gallons per minute with 5 pounds per gallon now. So this is information, important information. So these gallons per minute, because it's flow rate, so is this value 5 gallons per minute pumped in, okay, and with 5 pounds per gallon. So that is the concentration input. Also 5 gallons, 5 pounds per gallon. So that is the concentration input and the flow rate input. Now, what is the meaning of brine? Brine is salt dissolved in water. So that is the definition of brine. Okay, now, the well mixed solution in the tank leaves the tank at 1 gallon per minute. So the flow rate speed output is 1 gallon per minute. Okay, now you can see here that the speed input is bigger than the speed output, so that means that this volume is not going to be constant. So it's going to increase. Okay? And that is actually the question. What is the quantity of salt at its overflow? So when the volume reaches 400 gallons, which is the capacity, the problem is asking what will be the quantity of salt dissolved in the tank when it is about to overflow. All right. Okay, so let me do a timeline of the pens. Okay, so I'm going to do here a timeline T, and here let's say is the Q of T, the quantity of salt in the tank. Okay, because at the beginning it has 200 gallons of pure water. That means that the Q of T is equal to 0. So it is here. So this pure water, it's saying that Q of 0 is equal to 0. So that is actually an initial condition. Okay. So, and then it's going to start to increase because you are pumped in 5 pounds of salt per gallon. Okay, so it's going to increase until there is a point, a time here, time overflow. Okay, we have to calculate that time because that is not given. Okay, so how do we calculate the volume? Because the volume is not constant, and pay attention here. The volume, we have to calculate the volume as a function of time. The volume as a function of time, this V vol is not, don't confuse it with flow rate, it's different. That is the volume. Volume as a function of time is volume, initial volume. And what is the initial volume? 200 gallons. Plus, here I'm going to make a delta between the flow input and the flow output. So it's going to be the flow input minus the flow output times the time t. Does that make sense? Well, yes, because the flow rate, if you multiply times the time, okay, so you are going to cancel the time and you are going to get the volume, how many gallons it is flowing in. So that is the definition of how do we calculate the volume. So the volume as a function of time is going to be initial volume 200 gallons plus here flow rate input minus flow rate output 5 minus 1 is going to be 4 gallons per minute times the time, and these 200 are gallons, so here the time is going to be in minutes. So this is actually the time is going to cancel and you are going to get the volume. So the volume is equal, so I'm just going to write here just plus for the time, okay? Because I don't want to I want to keep a space for to answer the question, because we haven't even solved the differential equation, so I will need more space. So now, so what I'm going to do right now is to calculate the time overflow. Okay, so to do so, the overflow is actually 400 gallons, which is the capacity. So from here, I'm going to calculate what is the time when it is going to reach 400 gallons. So from there, we can see that this 200 to the other side is going to make 200 divided by 4. So that is 15 minutes. So that is the overflow time. So it is equal to 15 minutes. And they are asking how much is the quantity of salt dissolved in the tank at that time overflow. Okay, we haven't even solved the differential equation. So if you remember from the previous video, the derivative of the quantity of salt dissolved in the time, the flow rate is going to be equal to input flow rate times concentration. Input is going to be 5 times 5. I'm going to avoid the units to save space. Minus here is going to be the flow rate in output, which is just 1 times the concentration output, and the concentration output is the Q of T divided by the volume. Which volume? This volume, because it's going to be 200 plus 40. Okay, so this is a linear differential equation. The derivative of the Q of T respect to the time. This to the other side is going to be positive 1 over 200 plus 40. Sorry, it's fine. Times Q of T equal to 25. Here, because you have a multiplication, is 5 times 5, the concentration times the flow rate. Alright? Okay, so as you can see there, it is a linear differential equation where this is the P of T and this is the Q of T. Okay, so because it's a linear differential equation, we have to calculate the integral factor. And to calculate the integral factor is W of T is equal to the exponential of the integral of this number, 1 over 200 plus 40 differential of T. So we have to place here a 4 and 1 over 4 to compensate. And that is the natural lowering. So W of T is equal to exponential of 1/4 the natural lowering of 200 plus 40. And then this 1/4 goes as a power. So it's going to be, and the exponentials cancel. So W of T is equal to just 200 plus 40 to the power of 1/4. Okay, it's an ugly number, but it is what it is. Okay, so now let's multiply this times the differential equation. So if we multiply that, it's going to be like this: 200 plus 40 to the power of 1/4, derivative of the Q of T respect to the time, plus this times this. This has the power of 1. In that case, it's going to be minus 1. So it's going to be 200 plus 40 to the power of minus 3/4. Alright? Because it's going to be 1/4 minus 1 minus 3/4. Q of T is equal to 25. 200 plus 40 to the power of 1/4. Okay, so now we have here the dead step. The dead step here is this. That is going to be the derivative of only two things. Where are those two things? This, as it is, 200 plus 40 to the power 1/4, and this without the derivative is just q of t equal to 25 200 plus 14 to the power of 1/4. Okay, let's check if this is okay. So derivative of this is going to be this times derivative of this is here, and then this times derivative of this. So 1/4 is going to go down, and then 1/4 minus 1 minus 3/4. And what happens to the 1/4? Derivative of this is going to be 4, so that cancels. So looks good. Now this is a variable separable differential equation. So what we have to do is to pass this in a multiplication differential of t, and then apply integrals. Alright, integrals. Okay, this one is very easy because this and this cancels, so this is going to be 200 plus 40 to the power of 1/4 times q of t equal to integral of this. We have to compensate this. We need a 4 here, and we compensate with that with 4 here, because the derivative of this is going to be 4 differential of t. So this is going to be 25 over 4 times integral of this is going to be 200 plus 40 to the power of 1/4 plus 1, so that is going to be 5/4. Let me check if we have everything correct. Yes, seems to be correct. So it's going to be 200 plus 40 to the power of 5/4 divided by 5/4, and don't forget the constant. That is the constant. Okay, so let's clear the q of t. So the q of t is going to be equal to this. Now you are going to this as a division. So here, by the way, this 4 and this 4 cancels. 25 divided by 5 is just 5. 200 plus 40 to the power of what? 5/4 minus 1/4, 4/4, so it's equal to 1, plus the constant 200 plus 40 to the power of minus 1/4. Now, don't forget that this divides this, but also the constant. And the division of the constant, I just write it in the numerator. Alright? Okay, so that looks nice, but we still need to find the value of the constant c. To find the constant c, we are going to use the initial condition. At the beginning, the tank has pure water. So that means that q of 0 must be equal to 0. Okay, so let's see what happens. What will be the value of the constant so that the q of t is equal to 0? So let's do it. Q of t, q of 0 is equal to, here 0 is going to be 5 times 200 only, because this is 0, plus the constant. Here is going to be 200 plus 0, so it's going to be 200 to the power minus 1/4, and that is equal to 0. So the value of the constant c is going to be equal to this 2 times 200 times 5 is going to be 1000, then 200 to the power of 1/4. Okay, negative, by the way, yes, negative. So so let's calculate that in the calculator. Okay, so okay, so that is equal to C is equal to 3760.6. Okay, so the model is going to be that ugly number, sorry, but looks very ugly. Anyway, I'm just checking if I do any mistakes. So the q of t is going to be equal to 5, 200 plus 40 to the power of 1 plus the constant, that number 3760.6 times 200 plus 40 to the power minus 1 quarter. Okay, now let's answer the question. The question is, what will be the quantity of salt at the time of overflow? And the time of overflow is 15 minutes, so Q of 50, that is the question. So it's going to be 5 times 200 plus 4 times 5, which is going to be 4 times 5, and then plus 3760.6, 200 plus, here is going to be 4 times 50, and then minus 1 quarter. Okay, so if we do that in the calculator, Q of 50 is equal to how much? Okay, I have to do it by parts, so it's going to be 220 times 5, so this number is 1,100, okay, 1,100 or 11 hundredths, whatever you want to use, okay, and then plus 3760.6 times, here is going to be 220 to the power minus 1 quarter. Okay, let's see what is the answer. Okay, so sorry, this is minus. I forgot the minus. This is minus. Sorry, I forgot the minus. Minus, so this is minus. And this should be minus. Sorry for that. So let's do it again. So the result here is 123.54 pounds. So that is the quantity of salt dissolved in the tank when it is filled to the top. Okay, so that is the answer. Let's hope I didn't have a mistake. By the way, if you happen to find a mistake in the problems or in the videos, please let me know. I am open to corrections. All right. Okay, engineers, with this example, we are done with the first unit, and you can solve all the homework available in the course material web page, and then you are ready for the examination. Okay, see you on the next video.